So make sure you use this video to study because the problems we do today are going to be test level problems. Okay, so very important that we understand how to do them. So starting with number 1, and I would like volunteers to read today. We have quite a few problems that are word problems, and I'll definitely want some volunteers. So who can begin for us? Go ahead, Tyrone.
Margot has drawn a parallelogram and is giving you clues about it for a guessing game. If her first clue is that the parallelogram has 4 congruent sides but does not have congruent diagonals, which parallelogram could Margot have drawn?
Okay, good, awesome. 4 congruent sides, but does not have congruent diagonals. Matter of fact, let me put a poll. Go ahead. 4 congruent sides, but does not have congruent diagonals. Five seconds to vote. 5, 4, 3, 2, and 1. The winning result is answer choice B, which is correct. This is definitely going to be a rhombus. Now, the key words were that it has 4 congruent sides. What are the only options here that has 4 congruent sides? Yeah, it's either going to be a rhombus or a rectangle. I mean, or a square, But since it does not have congruent diagonals, then that's definitely going to be a rhombus. Just as a reminder, rhombuses are like kind of like if you think of a square and you pinch it, kind of like this. That's the best rhombus I've drawn in this entire class, you guys. But it looks something like this, where this diagonal, we've got 2 diagonals. Which one is longer? Which one's longer? AC, right? So AC is longer than BD. One is always going to be longer than the other on a rhombus, but on a square, they would be congruent. Okay, good. That was number 1. Any questions on number 1? Good. Starting off strong. Good. See, and I flipped to the next page, but it doesn't. This is why I hate technology, guys. It's not loading. I'll give it a moment. Let's go back to the old days. Yeah, I know. I wish. Come on. Nope, doesn't want to load. I knew it was too good to be true. Okay, let me try plugging it in. Because usually how I do it is I like plug it into my computer. But now, see what's happening? It's just a black screen. I don't know why. Why is that happening? Let me try it through the Bluetooth again. Okay. Okay, we're back. All right. So here's the second. Yes, this is the second problem. Okay. Will my Apple Pencil work? Yes, it will. Awesome. Here we go. Who can read problem number 2? Perla, go ahead.
Okay, I guess we're just popcorning people now. Okay. Parallelogram ABCD has coordinates 0, 7 and 2, 1. Which statement would prove that ABCD is a rhombus?
Okay. So we're given a little bit of information, not a lot. It's a word problem. I have coordinate points. What do I do right away? Draw our shape. Good. We know we're trying to see if it's a rhombus, so you might as well draw a rhombus and label it. And it's not showing up on my screen. Why is that? Okay, I'm just gonna let it load. Sometimes it just needs a little moment, okay? We're just gonna give it a moment. But what I'm doing right now is just drawing a rhombus, labeling it A, B, C, D, and then labeling the points A and C. I'm gonna give it its sweet time. All right. So draw your rhombus. Imagine that the one I drew is already on your screen. Oh, there it goes. Nope. I thought I was gonna make it, but nope. All right. I know you don't see it. Just imagine it. It's there, I promise. Oh, there it is. Okay. So what would prove that this is a rhombus? So what do we know about rhombuses again? Go ahead and shout out some
They
information.
have 4 congruent sides.
4 congruent sides. What else?
Diagonals are perpendicular.
Diagonals are perpendicular. Those are my most important ones, I think. 4 congruent sides, perpendicular diagonals. Well, if this is all the information I have so far, what do I know about this rhombus so far? Or what can I figure out about this rhombus? With what I have. What's like, I only have 2 pieces of information. What is the only thing I can really calculate right now?
Not the slope, right?
No, why not?
No. I don't know.
Can you calculate the slope?
Yes, but
Yes.
I said no because I don't know what we're gonna use it for if we do.
Well, what do we know about this? What did I just write down? What are the 2 things I know about rhombuses?
They have 4 congruent sides and perpendicular diagonals.
Okay. What does slope have to do with one of those things?
Oh, it has to do with perpendicular diagonals because we can find the slope and see of the sides and see if they're opposite reciprocals.
Okay, so this has to do with slope. There's your key piece of information. We can figure out the slopes and see if they are in fact perpendicular. Okay, so starting with the only thing I can calculate right now is the slope of AC. Okay, so the slope of AC. Okay, I'm going to use my slope formula. What's my slope formula? What am I going to plug into it?
y2 minus y1.
Mm-hmm. And what numbers go into that?
Is it 7 minus 2 over 0 minus 1? Or is it the other way around?
So be very careful. If this is my y2, which one has to be my y1?
Oh, 1.
There you go. So this would be 7 minus 1 over
0 minus 2.
0 minus 2. So this would be 6 over negative 2, which is negative 3. Okay? Now, if this is a rhombus, what has to be the slope of BD?
Wait, miss, what did you say?
I said that if this is a rhombus, what has to be the slope of BD?
1/3.
How did you get that?
It's since the diagonals are perpendicular,
Mm-hmm.
then I just switched it to be an opposite reciprocal.
Right. We know that it has to be the opposite reciprocal because that's the definition of a rhombus. So if one of those diagonals is negative 3, the other one must be 1/3. So my answer is answer choice C.
Miss, that was way easier than I expected.
Good. That's a good thing. That means that we're starting to understand it a lot better.
Miss, can I use the midpoint formula to find out if the midpoint of AC is actually oh wait. Oh yeah, 1,4.
You can, but would that give you anything? Would that help you solve this problem though? Like you can do that, but would it actually help you solve the
Oh yeah,
problem?
you're right. No, be a waste. That would be a waste of time.
It would be a waste of time because the midpoint that goes for all quadrilaterals, not just rhombuses, that the two diagonals bisect each other. That goes for all types of quadrilaterals. So it wouldn't help you get to the actual answer. Okay. Next one. Pictured below is quadrilateral QRST. Which statement is not sufficient to prove that QRST is a rectangle? So this one's a little hard because we're trying to figure out which one's false, like which one would not help us. Well, what do we know so far
About a rectangle or
about this particular rectangle?
um it's a quadrilateral.
We know it's a quadrilateral and because of the yeah, we only know about two of them though. Okay, we haven't been given the measurement of these angles yet. So we don't know yet if those are right angles. Now, if they are right angles, then we know it's going to be a rectangle, right? So the question is, which of these answer choices will help us to determine that those are right angles? So for example, actually, let's go from the bottom up. The answer choice D says, okay, if QT is parallel to RS. So if those two are parallel, do we know anything about the missing angles? Or is there a way to figure out something about the missing angles?
Uh I want to say that since they're parallel, they're gonna have the same slope,
Mm-hmm.
but if they're 90-degree angles, they can be perpendicular too. I don't know.
Well,
It's
remember, I put question marks there because we don't know yet if those are going to be 90 degrees. We want them to be 90 degrees, right? We want that. But it's not given to us yet. So we can't prove it unless I have a reason to prove it. So my question is, if these two sides are parallel, I want you guys to visualize something. Let's say I extend this and extend that. I extend this and I extend that. What do I have? Let me extend this one too.
transversal.
Yeah, I have a transversal. Think about it this way. QR would be a transversal, wouldn't it? Would we agree? QR would be a transversal of those two parallel lines. Well, what do we know about transversals? What can we figure out if you have a transversal? What do we know? Okay, think about a transversal. Think about what that means. What can you figure out from a transversal?
We can figure out if angles are congruent or if they're equal to 180 when added together.
Right, exactly. So think about it. If I have this angle over here and this angle over there, what would the relationship be between those two angles?
Wouldn't they add up to 180?
Yeah, these are supplementary because they are same side interior angles. And so if we know that one of them is 90 degrees, what does the other one have to be?
The other one would also be 90.
The other one would also be 90.
Miss, I forgot how to subtract for a second.
They have to add up to 180, right? So that one has to be 90. And the same thing can happen down here, hold on ST. That can be another transversal, which would mean that this angle over here would also be a same side interior angle to that one over there. So if one of them is 90, the other one has to be 90, okay? So long story short, if for answer choice D, if I know that QT is parallel to RS, I can conclude that QRST is a rectangle. But we're looking for which one is not sufficient, so this is not our answer. Questions on that answer choice? Because we're going to go to C now. So any questions on this one?
Wait, can't we eliminate QR and ST too? Because it will help us because if we make it in, oh wait, never mind.
So you're looking at answer choice A?
Yeah.
Okay, do you want to look at that one now, or do you want to go, like I was going to go to C next?
Okay, whatever you want, miss. I don't know.
Okay, well, okay, I'll go to C. So C is saying that Q is congruent to S. So what would that make S?
90 degrees.
Okay, so we know now that this one's also 90 degrees. Well, if 3 out of the 4 angles are 90 degrees, remember, a quadrilateral, the angles add up to what? For any quadrilateral, the angles add up to what? Tyrone, that's a triangle. Yeah, 360. They add up to 360. Well, if I have 90, 90, and 90, what does the last one have to be? Also 90. So with answer choice C, we can also conclude that QRST is a rectangle. What about answer choice B? It's the same thing, yeah. T is congruent to R. So this is basically the same thing. They gave us 3 out of the 4 angles. The last one has to be 90 degrees as well. So we can also conclude the same thing. So B is out. So let's look at A. Let's see why A is our answer. A is saying that QR is parallel to ST. So these are my these are my parallel lines, which means my transversals, it's kind of flipped. Now I have a transversal over here. Oh, it's not loading. It's okay. Let it load. It'll load. There it goes. Look, I'm writing with no hands. Okay, there it goes. All right. So this is kind of backwards to the one we did first. So now I have my two parallel lines are the top and the bottom, and then the two other lines are my transversals. But here's the issue. Can you compare one transversal with another transversal? For example, okay, so Tyrone says no. So for example, if this is 90 degrees, does that tell me anything about the other transversal's angles? And Tyrone says no, right? And Tyrone is correct. You can only compare within the same transversal. So I know that all of these are 90 degrees, but I don't know anything about the green transversal. You can't compare the two of them together. They're each going to have their own situation, okay? So for that reason, this is not enough information. Not sufficient. So that's why A would be my answer. Questions on this one? This one was a little bit tricky. So does anyone have any remaining questions about it? Cool. Moving right along. We do have a lot of questions to get through, so I'm glad we're kind of moving a little fast. Who can read this one? Oh, Perla. Thank you. Perla, actually, you get to popcorn it to somebody else.
Yay! Okay. You see my charms work sometimes. I'll popcorn it to. I don't want to torture people, but at the same time, I do. Wait, someone left. Okay. I don't know. You choose this. I can't choose. Next time.
Okay, I'm going to choose, let's see, who do I, Rios. Rios, go ahead and read this problem for us.
A parallelogram HAND is drawn below with the diagonals HN and AD, intersecting at S.
There's Samaj. Okay, cool. So which of these statements is always true? That's our keyword, always true. We want to make sure we have one that is not just sometimes, but always. So I have this parallelogram. We have, we don't know what type of parallelogram it is, but one of these statements is going to be true no matter what type of parallelogram. If you have a rectangle, a square, or a rhombus, it's always going to be true. So let's look at it. First statement is saying HN is 1/2. HN is 1/2 of AD. True or false? Okay, so I'm just looking at example or answer choice number 1. Answer choice 1 is, or A, is saying that HN will always be 1/2 of AD. False. That's right. That's false. Actually, we know that in a rectangle, what is going to be the relationship between those two lines? In a rectangle, what's true about HN and AD? Good, Tyrone. In a rectangle, HN would actually equal AD. Okay, so this is definitely not going to be true. It might be true for a rhombus, maybe, but it definitely would not be true in a rectangle. Second one, AS AS is 1/2 of AD. AS is 1/2 of AD. Tyrone says true. Okay, Tyrone is very sure that this is true. It looks like it, right? Because what do we know about S? S has to be the midpoint. And we know from the beginning of class, we wrote it down, we know that diagonals of a parallelogram bisect each other, right? So that has to be the midpoint, which means that this statement is true. Now let's just double check all the other ones. AHS is congruent to ANS. Well, first of all, do those even look congruent? Definitely not. If those were congruent, then this would be a rhombus. This is only true for rhombuses. And then finally, HDS is congruent to NDS, this one over here. Again, that would only be true in rhombuses. So yes, so B is the only one that's true for all parallelograms. AS is 1/2 of AD, mid-segment, or midpoint, I mean. All right, any questions on this one? Okay, here's one that is very similar. A lot of these will come up on your test. I saw it already. It's not that hard. Find the value of x in the figure below. So we have to remember, what do we know about parallelograms? So what is the relationship between these two angles? So I know opposite angles are congruent. So let me label these.
Miss Lopez, I have a question. Oh, never mind. But wait, still, I have a question. I need
Sure.
it clarified.
Mhm.
When it talks about opposite angles, like I always get confused with this. Is it talking about, let's say in this example, is it talking about A and B or A and D?
A, neither of those.
Oh, A and
No.
C?
A and C, yeah.
Oh,
A and C versus BD, B and D.
okay. So
Those are
basically,
your opposites,
okay. I understand now. Okay.
okay? A and B, what would those be?
Consecutive angles,
Consecutive, or there's one more word for it.
adjacent.
Good. Okay. I wrote it down. It's not writing. Just wait for it to come up. So in this case, A and D are adjacent or consecutive, which means, are they equal to each other or is it something else? Are A and D going to be congruent? No. No. What are they? They're not congruent. They're going to be what? Good, Jalen. They're going to add up to 180. So opposite angles are congruent. That would mean A and C are congruent, B and D are congruent. But if they're next to each other, they're going to add up to 180. So I know that A plus D equals 180. It has disconnected. Of course it has. Okay, there we go. We know that a plus d will equal 180, so I can just plug everything in. So 2x plus 7 plus 13x plus 18, plus 8, I mean, equals 180. Okay, I'm just plugging everything in. So now I have to combine like terms. 2 plus 13 is 15. So I have 15x. 7 plus 8. 7 plus 8 is also 15. Equals 180. Take away 15 from both sides. What's 180 minus 15? 165. And 165 divided by 15. 11. Nice job. So x equals 11. Now, for this type of question, be very careful. Always reread it at the end. Once you've finished your work, once you've gotten your answer, reread the question. Just make sure you have what you need. In this case, they're asking for the value of x, so we're good. But sometimes they might be like, what is the measure of angle A? What is the measure of angle D? They might ask you to plug that number back in to find a different answer, okay? So just be very careful. Read it properly, read it carefully, make sure you're entering the correct answer. Questions on this one? Okay, and just as a reminder, saying it one more time, opposite angles are congruent. That means A equals C and B equals D. Consecutive or adjacent angles are not congruent, but supplementary. That means that A plus B equals 180, A plus D equals 180, and all the other combinations. B plus C equals 180, and C plus D equals 180. Okay, any questions on that? Cool. All right, here's another similar one, but this time you have an X and a Y, and we know that this is a parallelogram. What do we know? And notice they're labeling all those different segments. What do we know about parallelograms that I can apply in this case? And let me label this M, so you can tell me using letters. What are some relationships that I can turn into an equation? Look at what you have. Which relationship can I use in this situation? There it is. So Perla said it. We know that the diagonals bisect each other. So in this case, I know that AM has to equal MC and DM has to equal MB. MB. Diagonals bisect each other. So these two are equal, and then these two are equal. So let's set up our equations. I know x plus 4 equals 7y minus 4 And I know 2x minus 4 equals 4y. Question so far?
No.
Okay. Well, what do I have here? I have two equations. Both equations have two variables. They're mixed and matched. Notice that. So does anybody know what I actually have here? This is something that you guys know from algebra.
Oh, can't we do system of equations?
Yeah, this is a system of
Yeah.
equations.
Oh my god, miss, I'm smart for once. I'm so proud.
Yes, so this is a system of equations. However, it is kind of all out of order, right? We are used to systems of equations. Usually they look like this. Like, for example, 3x plus 4y equals 12, and 2x minus 6y equals 17. Something like that, right? Usually that's what they look like, where everything is lined up properly in standard form. Well, are these in standard form?
No.
No, right? So what I need to do is kind of turn them into standard form by moving things around. So I'm going to rewrite them. The one on the top, if I move the 7y over, and then I move the 4, so basically I'm going to kind of like play a little game of like, what's it called? Musical chairs.
Rule?
We're just gonna switch those, okay? We end up with x minus 7y equals negative 4 minus 4, which is negative 8. Same thing with the bottom one. I'm just going to kind of switch these around. So I end up with 2x minus 4y equals 4. Questions on how I did that? Okay, now I have a system that I can solve because everything is lined up properly. However, if I want to use elimination, what should I do to my top equation?
Multiply it by -2.
By negative 2, good. Why negative 2?
Because we want them to be opposites so that they can cancel out.
Good. Okay, so I'm going to do that down here. So now I have negative 2x plus 14y equals 16. And then I have positive 2x minus 4y equals 4. I can add them up. My x's cancel out. I'm left with 10y equals 20. Divide both sides by 10. I get y equals 2. So I have one of my values. What do I do with that 2?
Don't we plug it back in to get our x?
Yes. So plug it back into one of the original equations, any one, and then you'll get your x. So I feel like I'm going to plug it into the one that I circled in orange. So I'm going to plug it into that one. Oops. Sorry. Do that again. Okay. So x minus 7 times 2 equals negative 8. 7 times 2 is 14, so x minus 14 equals negative 8. I add 14 to both sides. I get x equals 7, no, 6, 6. X equals 6. There you go. System of equations, they come back. Algebra never goes away. Trust me. I'm still doing it.
Yay.
Do I have questions on this one?
Janelle's would like some more time. She's just copying it down.
Okay. Okay, we're getting right through everything. Still need a second, Janelle, or are we good? Good. Okay. Next one. Similar one, but they labeled different things. It's a different problem. So this one's a rhombus. Rhombus. Okay. Let's list some things we know about rhombuses. What do we know? Just anything about a rhombus, and then we'll see what will actually help us. Diagonals are perpendicular. Good. What else? Four congruent sides. Good. Parallel sides, because it's a parallelogram. Anything else that might be useful for us? Diagonals bisect opposite angles. Good. Okay, and there's one more that I know is very important. Let's see if anyone, we haven't come up with it yet. There's one more thing that always makes it a rhombus. Opposite angles are congruent. Congruent diagonals, that's the one. Congruent diagonals. Okay, now we've got what we need. So I'm gonna go ahead, what I'm gonna do is I'm gonna label all of these things onto my diagram so that we can visualize it and then maybe pick out which one of these pieces of information is the most important. Starting with the first one, perpendicular diagonals. So I know that these are all 90 degrees. There's four congruent sides. That the sides are parallel. Opposite diagonals bisect opposite angles. So this one is congruent to that one. We have a lot of information, right? And then congruent diagonals. Okay, a lot of info, But only one of these is actually going to help us find our answer, because what we're looking for is DH. We're looking for DH. So I'm going to highlight it among all of these things we've written down. We're looking for DH. We know two things. We know that DG is 12 and HG is 20. Let's see if anyone can figure out, there's one amazing strategy that will help us find this missing side length X. Oh, Perla, to answer your question, you're completely right. This is actually not for rhombuses, it's for rectangles. So I'm going to erase that one. Okay. Anybody have any strategies that they want to try out? In order to find our final answer. We're looking for DH. That's our
Okay.
X.
Wait, aren't those gonna like be congruent those lines that are perpendicular? I mean diagonals with? So one side of that line. Wait, what letter is that?
The
That
D.
isn't okay. Wait, no. If EG, half of it is 12, right? The other half is gonna be 12. So
Mhm.
that means that one half. Wait, that means that the H has to be 12 because they like bisect each other.
They bisect each other, but they're not congruent.
Oh,
So EG is not, does not equal FH. So although that would have maybe worked, it's not going to work for us. Any other strategies possible? D is the midpoint, yes. Midpoint formula would work if we knew, if we had some coordinate points. Because remember, the midpoint formula is x2 minus x1 over 2, comma, y2 minus y1 over 2. So if I had coordinates, then sure, we could definitely use the midpoint formula.
Lopez, isn't it x1 plus x2 over 2?
Yes, you're right. It's addition. Sorry. So we don't have coordinate points. We can't use the midpoint formula. There's one crucial piece of information that we can use. Yes, the 12 and the 20 will be very useful to us. What's BH? I'm drinking iced tea. Area. Okay, area. Let me think about it so that I can answer for you. Well, area would tell me the area of the whole rhombus. Area wouldn't help me to find one of those side lengths. I mean, we don't even know the height, right? So if I wanted to do the height, I don't know the height. All I know is the base is 20. I don't know the height though. Okay, Perla.
Yeah, so I'm thinking, it's probably wrong, but maybe we can take it as a triangle. So you see how there's 4 triangles,
Mm-hmm.
but I don't know how we would find. Oh wait, it's we can use the Pythagorean theorem.
There it
Yay!
is.
I saved the day once.
There it
Awesome.
is. Okay, so what Perla said was the key thing to realize is that you have a triangle. You have a triangle where this is 12 This is 20. This is x. And it's a right triangle. Right triangles, you can use the Pythagorean theorem. A squared plus b squared equals c squared. Now, which of these is the hypotenuse? Which one's the hypotenuse? HD?
Oh, no. Wouldn't it be HG?
HG, yeah. Here's the hypotenuse. So this is C, and then the other two can be A and B. So this would be x squared plus 12 squared equals 20 squared. Let's do our math. 12 squared is 144. 20 squared is 400. Take away 144. What's 400 minus 144? 256. What's the square root of 256? Yes, 16. That's what you say. I wanted you guys to struggle through that one because once you realize that you're going to realize it all the time now, okay? Noticing that whenever you have a right angle, you have a triangle. You have a right triangle, and you can always use the Pythagorean theorem to figure out your final answers. So this was 16, which means the other one was also 16. And then that's it, we're done. Questions on that one? Okay, moving right along. I think this is the last one of these types of problems, and then we're going to do a couple proofs. So here we go. Which is the relationship that I can use in this example?
Wait, Miss Jalen said he had a question.
Oh, Jalen, what was your question? I'm sorry. Why is Perla? Okay. All right, so what relationship can I use in this example?
Wait. We can use the ones we used last time.
Which is what?
Opposite sides. Wait, opposite angles are congruent.
Mm-hmm.
Consecutive angles are supplementary.
Okay, so in this case, I have C and I have D. Are those opposite angles or adjacent angles?
Adjacent.
Which means they are supplementary. So I know that C plus D equals 180. So go ahead and try this one on your own. I'll give you guys about 3 minutes. Three minutes start now. Everybody's trying this problem. This is good test prep. If you don't try it, if you're just sitting there staring at your screen waiting for Miss Lopez to do the work for you, you are not helping yourself and you are not going to succeed on your test. Try it, make mistakes, and then we'll learn from them.
Miss, I think I did something wrong.
Share your answer privately and I'll tell you if you got it.
Okay, maybe it's because I did it all by hand.
All by hand. That's a good thing.
Yeah, but I probably messed up.
All right, there's 4 seconds remaining. Okay, that is time. All right. So we know they add up to 180. So here's my equation. I get 2/3 x minus 8 plus 46 equals 180. 46 minus 8, what's that?
Oh, miss, first I subtracted 46 and then I added 8, which is dumb, but
Oh, well, I'm combining them right away. So I got 38 equals 180. Now I'm going to subtract 38 from both sides. 180 minus 38 is 142. And then I have this fraction here. What do I have to do to both sides?
you have to multiply it by the reciprocal.
Good. So times 3/2. Okay, that cancels our reciprocal, cancels it out. 142 times 3, and then divided by 2. What is my final answer?
216.
216 or 2?
Oh, my bad. I'm sorry.
213. There we go. 213. C is our answer. All right. Questions on this one? This one was just a very, very algebra heavy question. Can you solve an equation? That's it. Questions on it? Okay. Yeah, well, we got to keep practicing those algebra skills, my girl, because they never go away. And especially next year when you guys have to take algebra 2, things are going to get hard really fast. You've got to make sure that you're practicing those things. Okay, I prefer algebra, honestly. I'm better at geometry. Like I scored better on my geometry final than my algebra finals, but I like algebra better because it's more like problem solving. Proofs. Proofs time. Let's do it. I don't want to hear complaints. Here we go. Given that quadrilateral WXYZ is a parallelogram, complete the proof below. We want to prove that angle W equals angle Y. That's what we want to prove. That W equals Y. Well, I can definitely fill that one in. But let's see how we can get there. So first thing, we know that, okay, it's given that it's a parallelogram. Let's go to the next one. WX is parallel to YZ, and WZ is parallel to XY. What is the reason for that? Good, Perla. Definition of a parallelogram. Okay. And Perla, whoever told you that is wrong. You're gonna go into algebra 2. Okay. Step 3. So let me fill in what I know so far. Now I know that these are parallel and these are parallel. I don't know about those yet. Next, they're telling me that WXZ is congruent to YZX, and WZX, do that in purple, is congruent to YXZ, this one over here. Why is that? How can I, what is my reason? Not ASA. Right. This is something else. Anybody else have an idea? Here, I'll break it down. Only the green ones. Only look at the green ones right now. How do I know that those are congruent? Give me any answer. Whoever gets it right, I'll give you 1 extra credit point on your quiz for this week. How do I know that those two angles are congruent? This should not be this. We have done this like 20 times. Give me all your guesses. I won't share who's right until the end. Okay, yes, Emily beat everybody to it. Emily is correct. Those are alternate interior angles. And so are these. Since we have parallel lines, we have a transversal, we have alternate interior angles. Okay, reflexive property. This is Tyrone's favorite one. What can I write here for step 4? XZ is congruent to XZ. Good. Let me mark it in there. Now, what do I have, Perla? You said it before. I did call your name because you mentioned this next step. You said it too early. ASA. This one's ASA because I have 2 congruent angles and 1 congruent side in between them. So my triangles are congruent. Triangle WXZ is congruent to triangle, let's see, YZX due to ASA. And then finally, I can state that my angle W is congruent to angle Y. What's that final reason going to be? What is it 90% of the time? CPCTC. Good. All right. That is this one. Any questions? This is a very common one. I would not be surprised if this came up on your test. So take a screenshot, take a picture, study this proof. This is a very popular proof. They love using it. So please make sure you study this one. I think we have time for one more. So let me choose the best one. Yeah. We'll do this next time. Okay, I'll do this one. We have all the statements. We got to fill in all the reasons. Here's what I want you guys to do. I believe you can do this. You should be able to annotate. When you click on annotate, do the text button and type in your answer using the text, okay? Because otherwise it's going to be too messy. Go ahead. I'll cross them off as they go. Good, reflexive is done. I'm just moving this up a little bit. Good. Alternate interior is done. Good. Okay, Tyrone and Perla, please stop that. Thank you. What happened to what? Who deleted their reflexive? Put it back.
I think that was me by accident closing the thing.
Oh, okay, I got it. Oh, you got it? Okay, he's got it. All right, keep going, guys. We're almost there. Just a few more. Actually, whoever did CPCTC, that actually goes here. So read it carefully, and then you'll see why.
Miss Lopez Janelis is gonna do the second one.
Okay, go for it, Janelle's. And then see if anyone can figure out what the last one is going to be. Good, Perla. That is the last one. Go ahead and put it in. And Janelle's, put in number 2 as well.
She's trying to figure it out because it's like a giant like box.
Oh no. Well, if you're typing, if it makes it a big box, that's okay. Just put it in
Put it on.
anyways.
She's gonna put it on the screen and then you can fix it.
Okay, I will. That is very big. Huh. I'm not sure how to make that smaller. That's so funny.
She did. We tried to help her make it smaller, but it
Well,
wasn't working. Like it was giant.
no, I know, Tyrone, I know. It's still, it just does this to it. So it doesn't work. That's okay. We're just gonna put it right there. Okay, good. We finished. See, this one was very similar. They always kind of follow the same exact patterns, okay? So this is another good one to study up. Take a screenshot, take a picture, study it. Make sure you understand the sequence, the orders of events, and you should be pretty good on that if it comes up on your test. Any questions? Okay. As a reminder, you have homework due on actually Friday, not Thursday. So let me fix that. Do Friday at midnight. And the test is when? When's the test? Good, 19th and 20th. Oops, 19th and 20th. Next Tuesday and Wednesday, because there's no school on Monday. So Tuesday, Wednesday. Then the following week, you guys are going to be forced to take iReady against my will, but it is what it is. Unfortunately, I can't do anything about it, but you guys know iReady is easy. You guys just have to do it, get through it, finish it. It shouldn't be too bad, and it will only count for extra credit. So I'll explain more on that later.
You remember how I told you I had a tragic story of the day?
Yes, what's your tragic story of the
Has
day?
to do with iReady. Oh my god.
Oh no, what happened?